In yesterday class, we started with HCF and LCM. HCF and LCM. Let's say we have two numbers, 84 and 198. How do we find the factors of 84? We try to tend to divide those numbers with some prime numbers and see what are all the factors of that number, right? Let's say we started with 84. We divided it by 2, we got 42. Then again we divided by 2, we got 21. Again we divided by 3, we got 7. Again we divided it by 7, 7. So the factors of 84 were 2 into 2 into 3 into 7 into 1, right? These were the factors of 84. Then again what we did, we went on and told, let's see what is the factors of 198, right? What are the factors of 198? Let's see the probable factors of 198. 198, again we divided it by 2, we got 99. We divided by 3, we got 33. We again divided by 3, we got 11. Again we divided by 11, we got 1. These were the factors of 198. I write down like this: 2 into 3 into 3 into 11 into 1. Now what we have to do is we need to find out the what we need to do. We need to find out the common factors, right? What were the things which were common for both? Here between 84 and 198, 2 are common, this 2 and this 2 are common. There's one more 2 here, but there is no one more 2 there. There is 3 and 3 which are common here, and there is 1 and 1 we are common. So highest common factor is multiplication of 2 into 3 into 1, which is 6. Then we went on to find out the LCM of it. LCM is least common multiple. What are the multiples? We just add everything together. 2, here 2 is there. This 2 into 2 into 3 into 7 into 1, I can write it as 2 square into 3 into 7. Then again 198 I can write it as 2 into 3 square into 11. Between 2 square and 2 here, which has a greater exponent? 2 square, right? Between 3 square and 3 here, which has a greater exponent? 3 square, right? Into 7 into 11. For LCM we take every term, all terms we include. So we get this as the LCM. Then again we went on to find a simple reason why this happens. We took 4 and 6. What are the common numbers which divides 4 and 6? 2, right? 2, 3. So what is the then HCF is? HCF is 2. After that, we also found out that there is no common number which will divide 2 and 3. So to find out HCF, what we have to do, we have to stop at the place where we have only commonality. To find out LCM, we will continue. 2 ones are, then again 3 ones are. So it ends up like this. LCM is now 2 into 2 into 3, which is 12. 2 into 2 into 3 is 12. Example, 12 divides by 4, right? Again 12 divides by 6. 12 divides by 6. So even though there are other numbers like 24 also divides 4 and 6, these common multiple is, what is the multiple of 6? Multiples of 6 are 6, 12, 18, 24, 30, 36. The multiple of 4 are 4, 8, 12, which is the smallest possible combined multiple of both two numbers 4 and 6, such that it should be the least common multiple. That is LCM. HCF is within the factors. What is the common factor? So HCF will somehow be the smallest number, though the name says highest. LCM will be a larger number, though the name says least, because the focus is on HCF is factors, where the focus on LCM is of multiples. This is how we then found out the LCM of again 3 numbers, which is 120 into 300 into 420. And 3 numbers we had. Common thing was 2. 2, if we do 60, 150, 210. If we divide it by 5, 12, 30 and 10. Some people had asked, what if I do it by 10? 120 becomes 12, 300 becomes 30, 42 becomes 42. Once you have enough practices, you can do this also. But you go step by step. Again, I went for 3, it is 4, 10 and 14. Again, I went for 2, it is 2, 5, 7. See, 2 is a prime number, 5 is a prime number, 7 is a prime number, 2. To find out HCF, it is a simple multiplication of 2 into 5 into 3 into 2, like this way. So we get 60 as the HCF. Let's say we take another number. And what we do? We find out. First we go by 2. So on, if I make it, I'll get 70, 90, 120, again 2, this number, again 2, I get this number, 60, again 3, I get 12, 15 and 20. So until now, if I wanted HCF, it will be the simple multiplication of 2 into 2 into 3, this much. Now there is no commonality, which is all the 3 found. So now I'll try to find the LCM. What I do, I again take 2, 6 are 15, nothing. It is not going to divide. So I simply write it like this. We are doing LCM here. I restate, we are doing LCM here. You shouldn't take, while you are doing HCF, if all the 3, if it doesn't divide, you should not take at all. LCM, you can keep it like this. Then 2 tens are 22, 3, 15 doesn't divide, 5 are 50, 5, 3 doesn't, 3, 5 will be 1, again 3, 1, 1, 3. So here is 2, how many times it is repeated? 4 times. 3, how many times repeated? 2 times. It's 5 here. So it is 720. 720 is our LCM. Then we again saw for 14, 20 and 30 and 45. HCF is for these numbers is 1 because they don't have any common factors. LCM we found. What we did? We went for 2, 7, 10, 15, 45. We went for 5. We got 5 3s are, 5 9s are. We went for 3, 3 1s are, 3 3s are. Again 7, I took it down. Now all are prime numbers, right? A simple multiplication, I'm getting the LCM here. Then again I did it for these numbers. You can check for these numbers. 2, for 2 it is 2, 3, 4, 3, 5, 1 and how much? 468. Again for 3 it is 78, 117 and 156. Again for 3, 26, 39, 52. Again for 39, 13, I get 2, 3 and 4. If I want to do the simple HCF, now what happens? Now if I am doing HCF and there is no commonality, there is no common number here to divide all the 3. So HCF is multiplication of all the 3. Here we had commonality which will divide all the 3, right? there are two properties of HCF. HCF into LCM is equal to product of two numbers. We'll be finding HCF and LCM for two numbers, right? That numbers. And between these numbers, HCF will always be a component of this number, like HCF into M, HCF into N, something like that. Example, you took example of 4 and 6 earlier on, right? 2 is the HCF. 2 is a factor of 4. 2 is a factor of 6. So within 4, there is a 2. Within 6, there is a 2. Here, 2 into 2 is 4. M here is 2. 2 into 3 is 6. N here is 3. HCF is 13. LCM is 170. First property we are applying here. One number we know 65. What is the other number? We calculated it as 156. We know two numbers which are in the ratio of A is to B, and 13 is to 9. And the HCF is 17. Especially when the HCF is 17 or any prime number, it means the given ratios are just multiples. We did it in detail here. So HCF will be a component. We saw, right, 4 and 6, how 2 is 2 inside is inside 4 and 6 is inside 4. So this component and this component is there. So what we have to do? 13 here. 17 into 13 and 17 into 9. Why? The ratio of the numbers is 13 into 17, 13 by 9, and 17 is the HCF. So 7 into 13, 17 into 13, and 17 into 9. We get the two numbers, because HCF is a subcomponent number of these numbers. We did further problems. I'll tell in part B of the video.